Okay, we're going to take a look at number 5 in section 2.8. And this deals with what we call the intermediate value theorem, or what I abbreviate IVT. We're going to consider this function here, and we're going to identify the intervals of length 1/4 which contain a root of the function. So 1/4 being, of course, 0.25. So roots are what? Are values of x that make this function equal to 0. And the intermediate value theorem says for any function that's continuous, right, which this function is continuous on its domain, it's just a polynomial function, on any interval where the endpoints, the outputs of those endpoints, one being positive, one being negative, it means that there is an output in between those two inputs where the output is going to be equal to 0. So graphically, all we're saying is, if I were to look at the graph of the function f, if I pick some interval and look at the endpoints, and if I say at this endpoint, the value of the function is, say, negative, that means that the graph is below down here. And at this endpoint, it's positive. So since it's continuous, I know somewhere between these connect these 2 points, this graph has to do what? It has to cross the x-axis somewhere. And that value of x would be the 0. Okay. So the intermediate value theorem says, you can take the endpoints of an interval and the outputs of those endpoints mean that what any value in between those two outputs, so this y value here and this y value here, somewhere in between here, that we're guaranteed there's a value of x such that the function is equal to any value in between these two. In particular, we know it's there's at least one value where it's 0. Could be multiple values because this graph could be going up and down. It might hit the x-axis several times. So all we're going to do here, they also talk about the bisection method, but this is not the bisection method. This is simply check these intervals to see if this case is true. Notice each one of these intervals, if you check, are all length 1/4. So like, from 1.05 to 1.3, that's a length of 0.25, right? So they're all length 1/4. So which ones are going to contain the root? Well, the easiest way I think to do this is to graph this function in the calculator, and that's what I've done here. Here's the function x to the 7th plus 3x minus 11, and then go to, make sure in table setup mode that you are in ask mode for the independent variable, and then go to table here, and you can now input your own value. So I can input the endpoints here, 1.20 and 1.45. Well, notice at 1.2, the output's negative. At 1.45, the output's positive. So like if this is 1.2 here, right, 1.20, the output's negative 3.817. And then at 1.45, the output is positive 6.8 something. So that means we do have a root on this interval. So I will go ahead and check this box here. And then what about from 1.25 to 1.5? 1.25, the output is negative, and at 1.5, the output is positive. So we're negative here and positive here. That means, again, we have a root on this interval. Let's do the next one, 1.3 and 1.55. Well, 1.3, again, we're negative. 1.55, we're positive 15. So again, there's a root on that interval. So the first 3 in this case. Now I go to this one, 1.05. I get a negative, and then 1.30, I get a negative value. Well, now what's happening here? If I'm looking at the graph on this interval, 1.05, 1.30. At 1.05, it's negative 6 something, right? Negative 6 something. So we'll say negative 6 is down here. And at 1.3, it's negative 0.82, so almost negative 1. So it's not as far down. So the bottom line is, going from here to here, it could be that the graph just looks like this, something like that, right? And then continues on or whatever. but it doesn't cross the x-axis. It could go up and come back down to this point, but we don't know for sure. So we're not guaranteed, right, by the intermediate value theorem that we have a root there. So we would not check this particular box. Okay. Okay. So we'll do the last one, 1.35, 1.6. 1.35 it's positive, 1.6 it's positive. Similar idea here, except instead of being below, we could be completely above. We don't have to cross the x-axis in between here, so I wouldn't check that box either. So that's all we're doing there, is just checking using the intermediate value theorem. Hope this is helpful on this one.